Welcome to part 3 for an intro to Azure monitoring. My name is Russ Maxwell. Its date of this recording is October 2nd, 2020, and I'm going to dive into the Kusto query language, also known as KQL. My ultimate goal with producing Azure videos is to make my viewers stronger technically and able to approach any scenario that surrounds the subject I'm presenting on. Feel free to subscribe to my channel, as I will be hopefully running across several different Azure components in the near future. The Kusto query language is fun to learn. It reminds me of SQL with a bit of PowerShell influence. In this session, I'm going to give you a very basic introduction of KQL in order to give you some exposure to this language. I will likely get more in depth with Kusto query language and cover more intermediate and advanced sessions at a later date. KQL, Kusto query language, it is used to query large data sets. It's performant. You will use KQL in Azure Log Analytics, Azure Application Insights, as well as Windows Defender Advanced Threat Protection. When you start with KQL, you start off with what's called a tabular expression statement. That's a fancy way of stating that we retrieve data from tables as a source of our queries. In my case, I'll be specifying a table that resides in a Log Analytics workspace. Do I want all the records for that table? Probably not. And so that's where operators come in. As you get more familiar with KQL, you will pipeline operators and additional statements to get more refined results. And that's what's interesting about KQL, is it also introduces elements of PowerShell, and that's pipelining. So pipelining is taking one output and inserting it into the next statement. And that process rinses and repeats across all the statements in a particular KQL query. Finally, you have data sources that are available to leverage. The one I will focus on is a table and querying against that table within a Log Analytics workspace. However, you can also work with functions and variables. All right, so it is demo time. This isn't covering every single aspect of KQL, but it should be enough to get you started on your path to writing solid KQL queries. In this demo, I'm going to first talk about my setup because it's a little bit different, and there's a reason for that. Next, I'll cover counting, finding, filtering, formatting, sorting, and time range. Let's begin. Before jumping into any KQL queries, I first wanted to show you how I set up this demo environment. And so Microsoft does provide some sample data that you can run KQL against, and that might work for you. For me, I wanted to be able to really understand the scenario that I'm applying KQL against. And that's why I built 2 custom tables with custom entries. And that's where I use this data collector API. It's a REST API that Microsoft made available, and there's some samples in here that you can leverage. And so that's exactly what I did, is I used these PowerShell samples and I pushed up my custom tables. What this looks like if I were to open VS Code is really simple, right? You just provide the customer ID, which is the workspace ID. You add your own primary key that's associated with the workspace. Specify the name of the table, which is the log type. And then your JSON is your actual data that represents the rows in that table. You can see I've added, about 11 different records. And these actually represent, in my demo scenario, I created 2 different tables that represented high schools, and within each table are students and some properties or things about that student: first name, last name, GPA, class, and school. And so I figured this would be a good kind of demo environment just to show you how I can get custom results based upon a scenario I'm interested in with KQL. Let's go back to the environment. So back into my Log Analytics workspace where I pushed those records, notice under custom logs I have 2 tables, Contoso High School and Fabricam High School. And I know they're custom logs. Not only are they categorized as such, but also appended at the end of each table name is _CL, which represents custom log. If I expand these tables, each column is appended with the type of that column. Okay, now that you understand the demo environment, let's go ahead and look at the table. In order to retrieve all the rows in a table with KQL, you always start with the table name. So I can either double click on this table or I can just type it in. And I prefer to type it in just because you can see a really cool feature of KQL, which is IntelliSense. And so I'm just going to run this table name and I get all the rows back for that given table. And so some of the columns I'm going to work against are first name, GPA, the class they're in. Next, I would say the most common operator is getting a count of how many rows you're working with. And that's a good validation technique if you're just building out your log analytics solution and you want to ensure that data is being populated correctly. This is where count can really help you provide that validation. It's real simple. This is where that pipe symbol comes in. So I'm taking the output of Kusto High School table and I'm submitting it to this count operator. So I'm saying, give me the count of all the rows. And that's exactly what it produces. So I've got 16 students in Kusto High School. Let's check Fabricam. Pipe count, and I will select rows 4 and 5, and I've got 11 students. Next up is summarize. And so this is another way to get a count of entries in a particular column that share the same value. In this example, I want to get the number of students in each grade level. And I can use summarize with count to make that happen. So instead of this, I'm going to pipe the summarize operator. I'm going to pass the count function by the column name, which is class S. So if I select those two lines, I get the class and the number of students in each class. Next up, we're going to talk about finding. This is very powerful. You can find a few different ways, and more often than not, you're going to be searching for strings or maybe looking where something is equal to something. And so the very first operator I'll show you as far as searching is using the search operator. And so this will search across all columns by default. In my case, I'm going to run, let me get the actual table results back first so you can see all the entries in here. And so the very first thing I want to search for is freshmen. I want to search all freshmen, so this will search all the columns. So I just pipe search and punch in the keyword I'm interested in, which is freshman. And this gives me all the freshmen. You can also append other things. So for example, I may want to search for two different keywords that reside in two different columns. You can do that too. So you just add and so I'm looking for any rows with freshman and Walker anywhere in that row. In addition, if you only know a partial of the keyword, you can also use wildcard searches. I can use search and I can use the asterisk symbol for that search. And so I wrap it in asterisks. And notice it's searching all the columns, but it's a partial of Walker, so I'm getting Buford back here. What if I know what column it's in and I just want to search for that column? That's certainly a better approach as far as the performance of your queries and the timing that it would take to run through all the rows. Where first name, colon, double quote, and the name itself. So where first name is Alan. And I do have a student with the first name of Alan. I can also do this as well using a wildcard. So if the first name contains an A, I can wrap it in stars and of course in quotes. And I'm only searching the column name. And so I've got a few different students that have an A in their first name. A more formal approach to using search is using where. And so you can find data based on a condition, and that's where is similar to search, except it's more optimized that you define. And so in this case, I'm going to specify the table name where class equals sophomore. So you can see I'm able to specify the column name. So this is where it starts to look a little bit like querying a SQL database. So those are all my sophomores. I can also append and look for strings that either maybe it starts or ends with a particular letter. So for example, if I wanted to look for somebody with a first name that starts with a T, I can say where first name has prefix T. So you can see the first name comes back. Just like prefix, I can also say if the first name ends with a Y. So I can use has suffix. So you can see I've got a lot of students where the first name ends in a Y. What about students anywhere in their first name where there's an M using where? Yes, you can use where first name and this operator called contains. And let's say the letter M. There. And so this gives me, of course, all the records where the first name contains an M. Pretty cool. What about an example where I want to filter retrieve results based off of numerical value? So in my case, I may want to retrieve all the students failing in order to do a follow-up with the school. So I do have this GPA column, so I'm going to use that. So let's say where GPA is less than 2.0. So Brittany and Tommy are in trouble. Maybe I just want to get a count. And so remember I talked about pipelining, how you can pipeline one statement to the next. It starts with the whole table being piped. I'm going to grab the results of who, where GPA is less than 2.0, and then I'm going to get a count of that. 2. So as your query gets more advanced, you're going to be adding statements and piping. What if I wanted to search based on values of 2 different columns? I can do that as well. And so, for example, I can just say where they're failing, and maybe I'm interested in finding out my seniors because whoever's failing is going to have some issues when it comes to graduation. So I need to find out who these students are. So I can just use the and. Let's talk about formatting the output. And so maybe I don't want all the columns. Maybe I just need to provide a list of students, but I need to omit PII information. And so I'm only interested in outputting the student ID, the GPA, the class, and the school. And so I can absolutely do that using the project keyword. So you project the columns that you want to output on the screen. Okay. So notice I've got the columns I'm interested in a result set. I can also create new columns using extend, and I can drop in whatever I want. And so this includes building a combination of values within a given row, or more advanced functionality like new data based on a condition. And so in this example, I'm going to create a full name column, and I'm going to add the first and last name of that user in a single column. So before it looks like this, right? And you can see I've got the first name and last name in separate columns. So I'm going to add those together to form a new column. And I will use extend to do that. And I'm going to call the column full name. And I'm going to assign it. I'm going to do what's called string concatenation, and I'm going to give it the first column, add a space, and the last name column. So you can see I've got, in addition to the first name, last name, I also have full name here. So in order to clean this up a bit, instead of having the first name and last name with the full name, I'll just project the columns I want. And there you go. Next up, you can also sort your results in a desired order by using the sort operator. So for example, I may want to sort GPA from the highest GPA to the lowest. And so yes, absolutely, I can do something like this. So it's exactly as advertised. So yes, you do have the ability to sort ascending or descending off a particular column. Okay. Finally, let's talk about time range. And you often will be using time range to narrow down logs to a particular period of time. Usually it's when a problem occurred. Often it's somewhere in the middle of your results set. So running the table query again to get all the entries back, you can see I've got a time generated field which represents the time the record was pushed into the log analytics workspace. And so I updated my query to show the time generated in descending order. This shows the newest entries followed by the oldest. And so what I'm interested in showing you first off is that I don't necessarily need to use the between operator in order to get a time range. I can actually just use the built-in browser functionality of time range. So clicking on this, if I want to use search, grab events for the last 4 hours, or grab the last 7 days worth of events, or I can set a custom time period. In my case, I'm going to use KQL to do this. And so what I'm interested in is only retrieving the records that occurred at 5:19 p.m. on October 2nd. And so in order to do that, I can use between with date time function and specify my starting and ending times. And so I'll paste it in what it looks like. And so here you can see I'm looking for the date time between 3:09. So it is a 24-hour clock, the query itself. And then I'm looking at the end date or the end time where I don't want to receive those particular records at 5:22. This should give me the results I'm looking for, which are just these 3 records. And there you go. The other way I know I'm using this correctly is the time range is set to set in query. Another way to retrieve results is using the ago function. So using the ago function, the first thing I need to do is understand what I want to retrieve. And so I want to choose a sweet spot between 3 p.m. and 5 p.m. So I'll choose 4 p.m. And in order to know how far back to go using the ago function, I need to get the current time. And so I'll run this print now function. And so currently it's UTC time and it's 10:03 at 2:31 a.m. And so getting to around that 4 o'clock period would be around 10 hours. And so in order to get to that 10-hour range, if I want to look at entries 10 hours ago or less, I could run where time generated and run the ago 10 hours ago. And that's going to give me those 5 o'clock entries. Notice I don't have the 3 o'clock entries. And so if I want to choose more than 10 hours, then I would flip the symbol. And you can see I've got my entries at 3:08. So that's the ago function. Again, I'll include resources at the end of this session so you can go check that out. And that wraps up the demo. So these are some KQL best practices. Use time filters first. So Kusto is optimized for time filters. The second bullet, for querying strings, use the has operator instead of contains. And finally, for searching text, don't use the star symbol or asterisk. Instead, look in a specific column. The asterisk does a full text search across columns, so it's not very performant. If you're interested in more KQL, please leave a comment in the comment section where I might cover joins, unions, and other advanced features of KQL. So here's what's next in the Azure Intro to Azure Monitor Series. So next up, alerts, and thank you. Have a good one.